I'm going to talk about integration in this form where we have 1 over ax squared plus bx plus c. And essentially, if we take b squared minus 4ac, that is less than 0, which means that essentially what we mean by that is that the bottom is not factorable. And so the idea is that we got to use complete on the squared. So let's take a look at an example. So what if we want to integrate dx over x squared plus 2x plus 2? Okay. Well, notice that the bottom is not factorable. Okay. And so how do we complete the square? Well, this is a time to review. But again, I got you. This is just some simple steps. And the idea is I'm going to take the middle term, I'm going to divide it by 2 and square it. Once I do that, I'm just going to add it to both sides. And so when I look at this, I could rewrite this as dx over x squared plus 2x. And the idea is if I square the middle term, the coefficient of the middle term, which is 2, if I divide it by 2, which is 1, okay, so let me do it on the side. So 2 divided by 2, and I square it. Essentially, I'm just dividing by 2 and square it. When I divide 2 by 2, that's 1. I square it, that's just 1. So the idea is that I'm going to add 1 to this. I still have my 2 over here. So if I add 1 to this side and I have my plus 2, I have to subtract 1 on the other side. That's the basic idea. Whatever you add beside the second term, you just subtract it from the constant. Okay. And so what this allows us to do is that we're going to look at the integral as dx. And what this allows us to do is write this in such fashion that we could get it in terms of u. So the idea is I'm going to take my x, I'm going to take the last term. So this is x plus 1. Okay. So I'm going to take my x, I'm going to take my x, I'm going to take my last term, I'm going to put a parentheses around it and square it. Okay. And so this idea takes care of this whole thing here. And so that's why I kind of leave them separate. And so 2 minus 1, that's just 1. So we have a plus 1 out here. Okay. And now once we get it in this form, the idea is that we now could get it in some sort of tangent. And so if we look at this, we could set our u to actually be x plus 1. Okay. Okay. Or u to be x plus 1. And so our du, or derivative, is actually 1 dx. Okay. So that's the idea. That's the idea. And what I'm essentially doing is that I'm using these as a substitution in for the integration. So if I look at this, this now becomes the integral of what was dx? That's just du. So this becomes du. And remember, u is x plus 1. Well, we have u squared plus 1. Okay. And so now if we take the integral, this becomes tangent inverse of u plus c. And we know what u is. Our integral is given by tangent inverse of x plus 1 plus c. Okay, so that's the general idea. So let's look at one that's a bit more complicated. So what if we wanted to take the integral of dx over x squared plus x plus 1? Okay, how do we do it? Well, again, notice that the bottom is not factorable. B squared minus 4ac is less than 0. And so if I look at this, if I take the middle term, which the coefficient, which is just 1, so if I take 1 and I take half of it, okay, if I divide it by 2 and I square it, well, 1/2 squared is just 1/4, okay? And so the idea is that I could rewrite this integral as dx over x squared plus x. I rewrite my middle term, and then I add my 1/4, okay? I still have a plus 1 out here. And if I add 1/4, I essentially have to subtract 1/4. Okay. And so remember the idea. If I look at this, this now becomes a pattern that we should see. So I could rewrite this as x plus, well, the square root of 1/4 is just 1/2. So this becomes x plus 1/2 squared, and 1 minus 1/4, that just gives us a positive 3/4. Okay, so again, notice the similarity between the first problem we did And the second problem now that the idea is that I'm just taking the square root of the first term and the last term, and I'm just squaring them. Okay, so I'm going to take the first term and last term, add them together and square them. Take the square root of them, add them together and square them. Okay, put them in parentheses and square them. And so now how do we deal with this? Okay, we can't just say u is actually x plus 1/2 squared. Because we have a 3/4 here, this is not 1. And so the idea now becomes that we got to rewrite this integral as dx over, we got to factor out this 3/4 here to get it to be 1. Because again, we know the tangent inverse has to do with x squared plus 1. That's the form. And so if I factor out a 3/4 here, this becomes, well, if I factor out a 3/4 here, well, I don't have a 3/4 times x plus 1, x plus 1/2 squared. Actually, I have a 1. So the coefficient in front of this is actually 1. And so the idea is this: if I multiply this by 4/3, then I'll get that to be 1 plus 1/2 squared. Okay. And plus 1. Okay, this parenthesis should not be here. It should be here. Okay. So ignore this boo-boo here. Okay, so look at the form now. I factor out my 3/4, so this becomes u squared plus 1. Okay. Now the idea is that now since we the term that we factored out, we really don't care about anymore. Okay, so let's keep that in mind. The term that we factor out, the last term here, because it's not 1, we don't care about anymore. And so if I look at this now, this becomes well, what is my u? What is my u? My u is actually well, the whole u squared is actually 4/3 x plus 1/2 squared. Okay, so hopefully we could see that. So u squared is actually equal to this whole term here. Okay, so u squared is equal to 4/3 x plus 1/2 squared. And we know that u, if we take the square root on both sides, well, the square root of 4 is just 2. The square root of 3 is just the square root of 3. The square root of this is just x plus 1/2. Okay. So again, notice the idea here. Once we factor out the 3/4, because it's not a 1, this whole term is our u squared. So we could set those equal to each other and find what u is. Okay, and the idea is that if we find what u is, we now got to take the derivative, so du, and we know this becomes 2 over the square root of 3 times the derivative of 1/2 is just 0, derivative of x is just 1, so this becomes 2/3 dx. And now the idea is that we found all that we need in terms of substituting for this, in terms of substituting in for this for integral. So the new integral will be written as follows. Okay, remember we said that we got to factor out this 4/3 here. So whatever number we write in terms of the parentheses, we got to factor it out. We don't care about the 3/4 anymore. And so if I factor my 4/3 out, this becomes 4/3 times the integral of, well, what is my dx? Okay, what is my dx? Well, I know du is equal to 2/3 the square root of 2 divided by the square root of 3. So therefore, if I multiply by the reciprocal, that will get the dx by itself. So dx is actually equal to the square root of 3 over 2 du. Okay, and so if I look at this, this becomes the square root of 3 over 2 du. So this replaces my dx. I'm going to divide that by, well, this becomes u squared. So this whole term is now u squared plus 1. This is u squared plus 1. Okay, so notice how I just rewrote my integral. Okay, now since this is a constant, I could factor it out. So this becomes 4/3 times the square root of 3 over 2 times the integral of du over u squared plus 1. Okay, if I simplify this, this becomes a 2. Okay, so this becomes 2 square root of 3 over 3 times the integral of du over u squared plus 1. Okay, and we know the derivative of du over u squared plus 1, or 1 over u squared plus 1 times du. That happens to be 2 times the square root of 3 over 3 tangent inverse of u plus c. Okay, now what is our u? This whole term here. And so if I look at this, this becomes 2 times the square root of 3 over 3. You're going to multiply that by tangent inverse of u, which is 2 over the square root of 3 x plus 1/2, okay, plus c. So this is what our whole integral is going to be given by. I forgot my equal signs here. Okay, now this number is also 2 over the square root of 3. This number here is also 2 divided by the square root of 3. Okay, but the general procedure, okay? So in this case, let me point out some differences here. Notice that when we got to this case, this was 1. And so we did not have to factor anything out, okay? This case, however, when we got to this part here, this was a 3/4. And so the idea is that tangent is given by tangent inverse, the antiderivative of tangent inverse. This maps to 1 over u squared plus 1. Okay, so that's the general form. Now we have u squared plus 3/4. That does not work. And so hence the reason why we had to factor it out and multiply it by the reciprocal, because again, we have a 1 times this here, not 3/4. Okay, so we had to multiply by 4/3. And notice that if I distribute this on both sides, I get exactly this whole thing here, okay? And so now the idea is that we don't care about this term anymore. So once we do that, we don't care about this anymore. This whole term with the coefficient in front of it is actually what our u squared is. And we just simply take the derivative to get our u, okay? And then we take, well, not derivative, we square both sides to get our u, and then we take the derivative to find what we need to substitute in for dx. The only thing I did is just manipulate to solve for dx. And then I simply factor out this term here on the front and then just substitute, okay? And this works for, this is the general procedure that works for anything that when you get to this part does not equal to 1.